Hi guys, today we're going to be looking at how to set up an error logging and monitoring system for your Node.js server, for your Express.js server. So the idea is, in production, logs get really messy. I mean, you have complex logic, a lot of things logging, a lot of things to the console, and you're processing a lot of requests essentially. So when errors happen, it gets very difficult to start digging through those logs to find information about that error, when it happened, the stack trace, and all that. So it really helps when you have like a dashboard or something like that that you can visit at your convenience and see errors that have happened and information about that error, the stack trace, where it happened, and all that. So to do that, we're going to be using this package called codewatch. So it's an error logging and monitoring system for Node.js. It allows us to capture errors on the server, and it provides that dashboard I talked about where you can see the errors and information related to the error. So yeah, this is what the dashboard is supposed to look like, and the rest of the README is just information on how to install, initialize, and use the package. So let's get into it. I've created a very basic Express.js application here. All we have here is just a very basic Express setup, importing Express Morgan. We're using Morgan to log information about our requests to the console, and we're listening on port 3000. That's basically all. We defined our routers and controllers in different files, as you would expect from most projects. So we have our routes here defined here. We have just a single route for now, and we have our controllers, these guys, we have them defined here. We have just a single controller for now, and we've wired all that up in the index file where we do the server setup. We've imported the route and we've attached it to this base URL, just a slash there. Let's ensure this runs, so we can just do npm run dev. I've attached a dev command here that does npx tsx. Tsx is a package that allows us to run TypeScript source files, and I'm watching it, so if we make any changes to the files, it should automatically restart the server, and the file we're trying to run is the index file. So you can start this. And yeah, our server is listening on ports 3000. So we have a single route. Let's check here, the /test. We can visit that to make sure it works. Localhost 3000/test, and we get that message, hello world. It's right here. Now let's see what happens when an error happens in one of our controllers. So I'm going to define another controller here. Exactly, test controller with error. So let's see how this works. I'm just going to save this, then we're going to create a route for that controller. Test, let's call that test error, and controllers.test with error. Cool. Now we should be able to go to the server has automatically restarted, so now we should be able to go to test error and see what happens. Oh yeah, I made a mistake there. Should be test error, not test J error. So we see an error message here, and that same error message gets logged to the console. So what happens is, we're not wrapping this error inside a try-catch block or anything like that. Essentially, we're not handling the error, but Express, because it happens on one of the routes, on this particular route, Express.js has a default error handler. You can imagine it as some middleware at the very bottom of all your routes. If any errors happen within the routes and they don't get handled, they bubble all the way down to that default error handler. And mostly what it does is it just responds to the client with the error message, with essentially the stack and all that. But you can imagine in a production environment where you have a lot of logs, a lot of things probably log into the console. This information, where the error happened and all that, the stack, it can easily get lost in that myriad of logs. So this can be very, very difficult to see in production. You would then have to start digging through logs to look for things like this to be able to debug where the error came from. So it helps when errors happen. You can just go to some dashboard and see exactly what has happened, the error that has happened, and essentially this and whatever other information you might need to be able to debug the error. That's what we're going to be doing now. We're going to be, let me stop the server. Alright, we're going to be installing some packages, some CodeWatch related packages. Luckily for us, CodeWatch offers an installer. So all we have to do is run this block of code here. I'm going to do exactly that. And we select the server framework that we're using. Currently it's just Express.js that is supported, so I'm going to select that. And the storage system is also just Postgres for now, so I'm going to select that as well. Okay, now that that's done, we can quickly look at our package.json to see what packages were installed. We can see CodeWatch core got installed, and that's like the core module for CodeWatch. You can see CodeWatch Express got installed. Actually, that's the Express.js plugin for CodeWatch. We also have the Postgres plugin for CodeWatch and the code for the UI. I think that's all. So let's go about setting it up. In our index.ts file here, I'm going to import the Postgres plugin from CodeWatch Postgres. I'm going to import a class called CodeWatch PG storage, and right about here, I'm going to initialize that. I'm going to instantiate that class, and yeah, the suggestions seem pretty correct. Yeah, I'm going to pass our database credentials. User, for my case, is Postgres. User, the host is localhost. Database should be CodeWatch. I have already created a database called CodeWatch, and password should be admin. Port 5432. That's what I need to do for that. And next we need to create this path code. Next we need to create, I've defined what my base path should be, but we need to instantiate the adapter and configure that base path. We need to set that base path. So what I'm going to do here is I'm going to import codewatch. That should be, I'm not sure what the name is. Codewatch. I'm going to import the adapter from Express. It's Express adapter, and I'm going to instantiate it right there. Data equals name Express adapter, and after instantiating it, I'm going to use a method on that instance to set base path. There. Good. Now after setting the base path, I think all we have to do is to get a router from this instance and attach the router as a middleware. It's essentially a middleware. Attach the router to that base path on our Express app. So what we have to do is get a router. Let's call it CodeWatch router. Or let's write CW router equals adapter dot get router. Then attach that router to our app.use. We're attaching it on the base path, so base path CW router. Yeah. And that seems to be all. Yeah, and finally, before the actual initialization would be to initialize codewatch itself, which means we need to import the init function from the core module, from codewatch's core module, and initialize codewatch using the storage plugin and the adapter, the Express.js adapter plugin. We can do that right about here. So I'm going to import codewatch core, and I'm going to be importing the init function here, init, and I'm going to pass in storage, and the server adapter should be adapter. Okay, I think that's all we need to do to be able to access the dashboard. Now what we've essentially done is we've configured all the plugins, the both plugins we're going to be using, as the Postgres PG storage and the Express adapter, and we've initialized codewatch with them and attached the adapter to our Express.js app. This should allow us to be able to access the dashboard on the base path we defined. So let's try and do that now. So we should be able to visit this base path. We should be able to visit localhost /code. So instead of test error, I'm going to go to code. Yeah, and we can already see one error here. I tested this before making the video, so while testing I created an error. I made the app do an error and it was able to capture it, but I forgot to clear the database before making this video, so sorry about that. I think I'm just going to pause the video and clear the database now so we can have a fresh start. Alright, I've cleared the database and now we have nothing in the dashboard. So this is the dashboard essentially. We can search issues. We have issues and we have statistics about those issues. We can search issues. Issues are essentially errors that happen on your server. So CodeWatch works with issues and occurrences. Occurrences are essentially occurrences of those issues. So once we start logging errors, once we start throwing errors, you would see errors on this dashboard and you'll be able to see information about the occurrence of the different occurrences of that particular error. So we have resolved issues, archived ones, and we can filter those issues by date when they occurred, and we can sort them by these various parameters. We also have statistics over here, just stats on the error occurrence on your server. So let's go ahead and throw some errors. Okay, so we're going to be looking at let's start with something more controlled. So we're going to be manually logging errors to the dashboard. We're going to be doing that using a function that is provided by the core module. Let me quickly create a controller to do that. Yes, function se manual. Let's just call it manual and request. Now what it does is inside a try catch block, we're going to be throwing an error. We're going to be throwing an error here in the catch. A handled one. Yeah, that's appropriate. And we're going to be catching that error here and logging it. So in order to log it, we need to import a function from CodeWatch core. and that function is the capture error function. So we're going to be capturing this error over here. Sorry, that's it. And once we've captured the error, it should respond to the client with, let's just see, done. Now, once I save that, the server should have restarted. We need to add this controller to our route, so we're going to do that here. Router.get, I just call it manual, and controllers.manual. And that's all we need to do. We can go back to the browser and visit that URL to manually log an error to the dashboard. Manual. Yes, and we get that response we wrote, done. Now if you come back to the dashboard, I should be able to go back to issues and I can see that error with the message we wrote, a handled one. It happened a few seconds ago and it's a few seconds old. Now if you click on that issue, we should be able to see the single occurrence we have of it, and this is the occurrence. You can click on it to expand it to see more information about the occurrence. So things that would have been lost in a multitude of logs, which is like the stack trace for example, we can easily see here. We can always come back to this to reference it. And we also get a few other things. We get console logs, essentially things that were logged to std out. In this case we get this essentially we get the request. Because we are using the Morgan middleware, we, like I said earlier, our request information about our request are logged to the console. So that's the only thing that we've had so far, and we get that logged here. And finally we get some system information, which is device memory, frame memory, app memory usage, device uptime, and app uptime. We also get std error logs as logs that were sent to std error, but that happens because the only reason we did not get it here now is because nothing was actually logged to std error. But let's continue. Now let's log more occurrences. I'll do that by just refreshing this page, by essentially throwing that error over and over again and capturing it over and over again. So if I come to statistics, we already have 5 occurrences because that's the amount of times I refreshed this, I visited this link. 5 occurrences of that particular error which we've captured. And if I go to issues, click on that, I should be able to see information on all those 5 occurrences. Now you see way more things in the log because way more things were sent to std out, and we still the stack trace of that and the system information at the point where this occurrence happened, then more information on other occurrences as well. Now that's great. So but this is more of a controlled situation. We know where the error is going to happen, so we are wrapping it in a try catch block, we are catching the error and we are sending it to the dashboard. What about uncontrolled situations where some unknown part of our app just throws an error? For example, in here outside the route, I can just set some timeout, see 5 seconds after the application starts. Sorry. It should throw an error, be delayed, handled error. No, this error is out of the reach of the default Express.js error handler. So an error like this would crash the server, which it has done in 5 seconds just now. Yeah. So the point is, codewatch should be able to capture things like this. That's the entire point. Well, the problem with this is because codewatch is, in order to be free, uses your resources, meaning it's on your server. So if your server goes down, you wouldn't be able to access the dashboard unless you have codewatch configured on some other server, but using the same database credentials as the one you're trying to monitor or something like that. But other than that, you wouldn't be able to access this dashboard if the server is down. But it's still useful when you want to say debug in retrospect. I mean, you start it up in development or something like that, and you want to be able to access the dashboard, or you, like I said earlier, have another server that has codewatch configured, and you can view it from there even if your main server goes down. So let's confirm that this error was captured. I'm going to comment it out so it doesn't take out our server again. And on saving that, our server has restarted, and we can come back to statistics. You can already see that got captured because we have this a new occurrence. It was 5 before, now it's 6, and we have this unhandled occurrence, one of them. And check statistics, we get that here, a delayed unhandled error. We get this flag that actually shows us it was unhandled. It was outside a try catch block or anything like that. If we click on it, we can get information on what happened. Now you can see what happens. It gets logged to std error, right? And we can see the single log we had before the error happened, just server listening on port 3000. We get the same information we got in other errors like the stack trace and system info. Next, let's look at errors that happen within routes, but are unhandled, meaning we did not wrap them in any try catch block, or we did not attempt to handle them in any form, but probably they are handled by Express.js's default error handler. Let's look at how those work and how we can work around them. We have an instance of such here. In this controller, test controller with error, we have this unhandled error. I mean, it's not wrapped in any try catch, and it's most likely going to be handled by Express.js's default error handler. I think we already have a route that has this controller, test controller with error. Just going to look for it here. Yes, we do. So let's just visit this then. Instead of manual test error, single slash. Yes, it does get handled by Express.js's default error handler. So we expect that to be logged to the dashboard, but no, it doesn't. It doesn't get logged because it gets handled by Express.js's default error handler. I mean, it happens inside the routes, then it bubbles down to that error handler, and it doesn't actually destroy this. It doesn't crash the server. Destroy is powerful. It doesn't crash the server like unhandled error does. So it doesn't get captured like that, and we're not manually capturing it in our routes, but we also still we definitely still want information about such errors. So let me show you how to capture those. We could always try and wrap all our controllers in try catch blocks or something like that, but there is a more convenient way of handling things like this, and which would be to, let's see, in our index file we can come to the very bottom and add our own error handler, and the error handler would allow us to capture, in the error handler we can capture that error and log it to the dashboard. So CodeWatch provides a convenient way of doing that by just we can create an error handler. We can say error handler equals, and the adapter, the Express.js adapter for CodeWatch provides a method that allows us to do that, to create error handler. Now you can configure your own error handler by passing in an optional handler method, but I'm just going to use the default for now. And all you have to do is app.use error handler, that's all. And now any errors that happen within the route should bubble down, should bubble down to our error handler here. Now the thing with CodeWatch is if you pass in your own error handler, you configure your own error handler, it sends it to that error handler instead of allowing it to bubble down to Express.js's default error handler. But if you use the default as I have here, it allows you to go through because something has to handle the error. All codewatch wants to do is log the error, then it calls next. It passes it on to the next middleware in the chain, which in this case, because we're not configuring ours, which in this case it would then be Express.js's default error handler. Hope that makes sense. So let's go ahead and test this. The server has restarted, so I should be able to revisit this. That there was an error here. It still sends it to Express.js's default error handler, so we still get this message. But then I should be able to come back to issues, and now I have a new error. A few seconds ago, last seen is a few seconds ago, an error occurred. Now, when you click on that error and you open occurrences, you see something we haven't seen on other errors. We see this context part here. Now, because the error handler has context on what route the error occurred on, it's attached to Express itself. I mean, our Express.js app. So it has context on what route it occurred on. It can provide context on different things about that particular request. For example, the method, get, the original URL, the host name, the path, protocol, and the IP address. So this might also be useful for when debugging errors. Other than that, we still get the standard stack trace, std out logs, std error logs, because again, as I mentioned earlier, Express.js's default error handler logs this error to std error, so that got captured here and we get the system info as usual. Now there are two more things I want to show you guys, which is capturing custom errors. That's essentially the same as capturing normal errors. I just wanted to show how it's displayed on the dashboard, and finally capturing just normal data instead of errors. So let's get into that. So imagine we had a custom error somewhere. I'm just going to define a custom error class here. So class extends error. Now for this custom error, let's assume we want it to have a, let's see, a code property. Code should be a number, and define a constructor. You should take a message like a normal error, and you should take a code. Then we call super. Yes, we call super, attach the code to the code property, and the name of the error should be custom error. So if we are doing custom errors in our application, let's see how that will get displayed on the dashboard. We're going to create another. Let me just copy the logic we have here. Custom error, to create another controller. Now we're going to be throwing a custom error, and see it requires us to add a code. Let's say the code is 500. Let me just change the message. A custom error with a code, and I don't want to wrap this one in a try catch block. I could, but let's just leave it this way. And now let's add a route for that. Router get custom controllers that custom error. Now the server has restarted. We should be able to visit /custom to do a custom error. Yes, we get a custom error here, and now I should be able to visit here. We can see that now the name of the error. So what codewatch does is it checks the name of the error it's capturing and uses that as the name of the record on the database. So if you're using custom errors, it would be very, very easy to identify what is what. So we have custom error here, the message, and the thing with custom error is it has the reason you might be using custom errors in the first place, apart from being able to just straight up tell what has happened from the name of the error, yeah, it also allows you to capture some extra data. For example, in this custom error, we added a code, right? The thing with codewatch is, it's apart from all the other information you get previously, it also captures that extra data under this manually capture data custom error props. We have code 500, which is what we threw, what we attached to the custom error here. And obviously you get all the other things, std out logs and std error logs, as well as system info. Now, assuming you're not trying to capture errors, obviously you would be trying to capture errors, but assuming you also wanted to capture some data at some arbitrary point in your code, you just want to know this is happening, or whatever other reason you might want to capture data, you can also easily do that using codewatch. It also exposes another function, capture data, that you can use to log data to the console, to the dashboard rather. So let me quickly define another controller over here and call this one data. Now this one doesn't throw an error, remember we're just trying to log something, so I'm just going to say capture data, and the data we want to capture, let's say foo, the value should be bar. Yeah, so we could do this, we could leave it as is, but the capture data also allows you to pass an options object where you can specify the name of that data. If I press Ctrl space here, you'll be able to see the options you have. You can specify the message of that data, and you can specify the name of that data, essentially allowing you to configure the things you see here, the name and the message. So when I leave it blank, right, when I leave it blank, let me quickly wire this up. I'm going to add the controller to the route. Let's create a new route for that. Get /data, and we can check that there, data. Oh, okay, we have an issue. This is going to load forever. It's going to load indefinitely because we are not responding to the client. We've only captured the data, right, but we are not responding to the client at all. So what we want to do here is rest or send something. Let's just send done for now. When the server is restarted, we can go there and try again, data, and now we're responding to the client. We're done. If we can come back here, and we should have two occurrences of that data. Now we have anonymous data because we did not pass a name or a message or anything like that. It gave us a name, and that name is anonymous data, and we have two occurrences of that. The first occurrence is when we did it without responding to the client, and the second occurrence is when we did respond to the client. No message was passed, just this. We have an occurrence of that anonymous data. This is the data we captured, foo and bar. We have a stack trace where we captured that data. Essentially everything you would have if it was an error, but you triggered this yourself. I mean, you wanted to capture data, and you have the several occurrences of that data being captured. So you can imagine this being dynamic data. I mean, it might be user data, it could be anything you might want to keep tabs on, you want to be able to monitor from a dashboard. Now let's do this with options. So we want to name it, let's give it a name, let's say captured data, and the message should be yes, this is some data captured, plus let's just add a bit of randomness to it, math, or yeah, I forgot the function to generate a random number for a moment. Yeah, I'm just going to add a space to this. Yeah, now we have some data we want to capture, and we have the name for that data and the message that we want to attach to that data. So if we come here and revisit this, still done, we can come back, refresh this, and we have that new data, that data here, captured data. This is some data I captured, 0 points, the random number we attached to it. You can see that particular occurrence now has a message, and we have that data over here. If I come here and capture it multiple times and visit this multiple times, I should be able to see a lot of occurrences for that particular issue, which is that data I captured, 11 occurrences. When I click on it, I can see all 11 of those occurrences. I can see all the different messages that were logged and whatever was captured for all of them, the data, logs, system info, and the trace. So, and oh, one more thing, guys. I also want to show you guys how to ensure you get the correct stack traces when you're using TypeScript for your project. So, you know, when you use TypeScript and you compile your TypeScript into JavaScript, sometimes you maybe compile into common JS code. The line numbers on the compiled code, on the transpiled code rather, doesn't always necessarily match exactly what you wrote. Let me show you an example. So for all the code we've written here, I'm just going to stop the server over here, and I have my ts config. The module is set common JS, so I'm just going to compile all this. And to do that, I'm just going to run npx tsc. That should emit our compiled code to the dist folder. We configure that here out. The output directory is dist. So if you look at your index.js file, yeah, this is the transpiled index.js. You can see this isn't what we wrote. This is what we wrote. It's essentially ESM. I mean, we wrote it using this ESM style, the import and everything. But here we have requires, and we have essentially longer lines. So you expect that a stack trace coming from this wouldn't exactly match what you have there, and in more complex applications this gets much more complex, right? So you would essentially, if you come here, you would be seeing something like controller .js. Let's see if we have that here. Yeah, over here, let's compare this to our controller.ts. Right, this is what we have with the custom error, the imports, and this happens on say line 15. If you look at controllers.js, line 15 is completely different. So if you have a stack trace emitted from here, it wouldn't exactly match what you wrote, and it might get difficult. I mean, tracing your steps, like looking for where the error occurs. Codewatch solves this for us by allowing us to leverage the source maps that might be generated with your transpiled code, which is this essentially. The source map is essentially a way of mapping the transpiled code back to the original code. So it would allow CodeWatch to be able to say, okay, this error occurred on here, line 15 here, but that transpiles to line 13 on the original code. So what you would see here would not be what you would see here would actually be the line number that corresponds to your original code, not the transpiled one. Yeah, but this is not the default. You would have to configure that. So I did that by enabling source map true right here in your ts config. That's all you have to do. Let's see what it is like without it. So over here, I'm going to transpile the code again. Let's refresh this. We still have these source maps, so let me just delete this dist folder and do this again. And yeah, the source maps are gone. So without the source maps, let's see what it is like running in production, because this is the code that is going to be running in production in reality. So let's see But we're not going to be doing npm run dev, because that, like I mentioned earlier, runs our TypeScript files. We're going to be doing node dist. We're going to be running that particular file, the index.js file itself. Index.js. So we're listening on port 3000. If I refresh this, it should still be here. That's great. But now when we, let's see, log something, if I come here and I visit this issue again, now you can see it has created a separate issue, because this happened on a completely separate line number. When we click on this, it doesn't log it under the existing issue we had before, right? Because it looks like a separate one, because it happened in a separate place. So if we open it and we look at the stack trace, we can see this happened where? At data in where? In dist/controllers.js. So this, and on line 35, this is referencing not our original code, but this, our transpiled code. And line 35 corresponds to this over here. This is definitely not what we wrote, right? So we don't want this. This is not necessarily useful for us. It would make sense if the line numbers correspond directly to the original code, which is what we wrote, and all we have to do to make that happen is just in our compiler options in tsconfig, you just have to enable source maps true. Let's restart the server. This won't automatically restart because we're using Node.js itself, not anything else. Node. I need to recompile so we can generate the source maps. So npx cnc. And now we have the source maps. This is the source map for the controllers.js, and this is the one for index.js. We should be able to run node dist/index.js. Right. And over here, if I redo this, I should come back here, and now we can look at this error and check the stack trace and see that it maps to controllers.ts line 37, which is our original code. This is some data I captured. Let's confirm that. Line 37, that is this over here. Yep, pretty much. So that's it. That's how to enable source maps and allow codewatch to leverage it in order to get more accurate stack traces on the dashboard. So that's it, guys, and that's it for this video. I hope you guys found it useful. If you did, please smash the like button and maybe leave a comment below. And that's pretty much it. Have a nice day.